Hello everyone. In this video, we are going to solve the problem number 1.57 from Irodov, and that is related to kinematics. So let us first understand the problem and then we will solve the problem step by step. A round cone with a half angle alpha is equal to 30 degree and the radius of the base r is equal to 5 centimeter rolls uniformly and without slipping over a horizontal plane as shown in figure 1.8. So this is a cone with the half angle of alpha is equal to 30 degree and the radius of base of this cone is given as r is equal to 5 centimeter and it is rolling without slipping. That means at the bottommost point is at rest and velocity is equal to omega r, and angular velocity here, if we consider any point in this particular periphery, then the angular velocity is given as the velocity divided by the radius of this particular base. Okay, the cone apex is hinged at the point O, which is on the same level with the point C, the cone base center. The velocity of point C is given as v is equal to 10 centimeter per second. Find the moduli of the vector of angular velocity of the cone and the angle it forms with the vertical. So let us say the velocity of this cone is given as v is equal to 10 centimeter per second, which is tangential to this particular circle. Okay, so if we talk about the angular velocity of this particular cone, so it is having two component of angular velocity. If we carefully look at here, this particular point is rotating in this periphery. Okay, and the entire cone is rotating about point O, about this particular axis in this periphery. Okay, so that's why we will have two component of acceleration. The axis through which it is rotating first is this one, as this particular point is rotating in this particular periphery, and the second axis will be this one, as the entire cone is rotating in this particular circle. Okay, so here let us say this is x direction and this is y direction. Let us say the angular velocity of about this particular axis is omega 1 and the angular velocity about this particular axis is omega 2. So we can write the net angular velocity is equal to omega 1 I cap plus omega 2 j cap. Please note it here that this particular direction is keep on changing, it is not constant. Okay, because let us say the cone has moved to this particular point, to let us say it has reached to here, then in that particular case the direction will be here. So I have written it here I cap for this particular configuration only, but it is keep on changing. And omega 2 having both the magnitude as well as the direction is constant because it is always towards the y-axis. Now let us first find out the angular velocity omega 1, that we can write it as velocity divided by the radius of this base, as this particular point is rotating in this circle. Okay, so from here we can get omega 1 is equal to velocity is given as 10 centimeter per second whole divided by 5 centimeter. So from here we will get omega 1 is equal to 2 radian per second. Now let us talk about omega 2. So if we talk about the center of the base of this particular cone, then center of the base is actually rotating in the bigger circle. Okay, so if we want to find out this particular omega 2, then we can write velocity whole divided by this particular length. Let us denote it by L. So we can write omega 2 is equal to velocity whole divided by L, that is equal to 10 centimeter per second divided by L. Now we have to find out this particular length. For that, let us take the projection from top side and we can draw the triangle. So in this particular triangle, let us say this is point O, this is point C, and this particular distance is given as R, and this is the length L. Okay, and half angle of this cone is given as 30 degree. So from here we can write tan of 30 degree is equal to R divided by L, and tan of 30 degree is 1 by root 3 is equal to R by L. So from here we can get L is equal to root 3 into R. Let us substitute it here. So we will get 10 divided by root 3 into R is equal to 5 centimeter. So from here we will get 2 by root 3 j cap. 2 by root 3. Now if we talk about this particular configuration, so we can write omega vector as omega 1 is 2 I cap plus omega 2 is 2 by root 3 j cap. Let us find out the magnitude of angular velocity. That we can write it as 2 whole square plus 2 by root 3 whole square under root, as both I cap and j cap are the unit vectors and both are perpendicular to each other. So from here we will get 4 plus 4 by 3 under root, that is equal to 16 by 3 under root. So this is the magnitude of angular velocity we got. Now in the same problem it is asking to find the angle between angular velocity vector and vertical direction, and we have defined the unit vector in the vertical direction, that is j cap. So we can write cos theta is equal to omega vector dot product with j cap whole divided by magnitude of omega vector and the magnitude of j cap. Omega vector that we have found out, it is 2 I cap plus 2 by root 3 j cap dot product with j cap whole divided by magnitude of angular velocity vector is 16 by 3 under root, and the magnitude of j cap is 1. So from here we will get 2 by root 3 whole divided by 4 by root 3 is equal to half, and for cos theta is equal to half, theta will be equal to 60 degree. Okay, so this is the angle we got, that is the angle between angular velocity vector and the vertical direction. Let us talk about B part. In the B part we have to find out the moduli of the vector of angular acceleration of the cone. Now in the B part we can write the angular velocity vector. Let us denote it as beta vector, that we can write it as d by dt of angular velocity vector, that is equal to d by dt of omega 1 vector plus omega 2 vector. Okay, now if we carefully look at here, then omega 2 vector has the magnitude as well as the direction, and both are constants, because magnitude that we have found out here, that is 2 by root 3, and it is constant, and the direction is always towards the y-axis. But if we talk about omega 1, then if the cone is changing its position, then the direction of this omega 1 is changing. Okay, but the magnitude of omega 1 is also constant. So let us say the cone has rotated by the angle of theta about the vertical axis. So let us say the angular velocity vector omega 1 is now in this particular direction for after rotating by the angle of theta. So basically if we write the omega 1 vector, that we can write it as omega 1 cos theta I cap plus omega 1 sin theta k cap. Why k cap? Because in the xz plane is perpendicular to the y-axis. So this is the z direction. So this is x direction, this is z direction, and the angular velocity will have the component in the x direction and the z direction. That's why I have written here it as k cap. Now let us substitute it here. So we can write d by dt of omega 1 cos theta I cap plus omega 1 sin theta j cap, and the derivative of omega 2 is 0 because both the magnitude and the direction of omega 2 is constant. So omega 1 is constant, so let us take it outside. So we can write d by dt of cos theta I cap plus d by dt of sin theta j cap. The differentiation of cos theta with respect to time, we can write it as minus sin theta, and the derivative of theta is d theta upon dt I cap, plus derivative of sin theta is cos theta into derivative of theta is d theta by dt. We are applying the chain rule. Okay, so from here we can write omega 1 minus sin theta. What is d theta by dt? If we see here, the point C is rotating in this particular circle with the angular velocity of omega 2. So as we can write theta, the derivative of theta with respect to time is omega 2. So d theta by dt, we can write it as omega 2. So from here we will get omega 2 I cap plus omega 2 cos theta j cap. So from here we can write omega 1 omega 2 minus sin theta I cap plus cos theta j cap. So this is the angular acceleration vector we are having. Now let us find out the magnitude of this. So we can get omega 1 omega 2 minus sin theta whole square plus cos theta whole square under root sin square theta plus cos square theta is 1. So from here we will get the magnitude of angular acceleration vector is equal to omega 1 omega 2, and omega 1 we have found out as 2 and omega 2 is 2 by root 3. So from here we will get 4 by root 3 radian per second square. Okay, so we have found out the magnitude of the angular acceleration vector and the magnitude of the angular velocity and the angle between the angular velocity vector and the vertical direction. I hope the entire procedure is clear. Thank you.